In this video we're going to continue with trigonometry and we're going to solve more trigonometric equations. So we've previously solved trigonometric equations in the higher course, but this time we're going to solve equations which require the use of the double angle formula. So we've got our double angle formula here, which hopefully we are very familiar with by now. And like I said, we are considering trigonometric equations which require the double angle formulae to find solutions. So let's look at example 1 here. We're asked to solve sine of 2x plus sine x equal to 0 for x lying between 0 and 360. So we need to recognise here that we've got a double angle, so sine of 2x, and we need to be able to use our expansion here. Okay, so we need to replace the sine of 2x with 2 sine x cos x, and we've got our existing plus sine x equals 0 here. Okay, and now we can factorise it. We've got a common factor of sine x, so sine x multiplied by 2 cos x plus 1 is equal to 0. By the null factor theorem, we know that sine x is equal to 0 and 2 cos x plus 1 is equal to 0. And solving our second one here, cos x is equal to -1/2. Now, we're not interested in what sine x and cos x are equal to, we're interested in what x is. So we need to solve each of these. So firstly, we'll look at sine x equals 0, and that's something that we can look at the graph for. So where is sine x equal to 0? And remember, it's between 0 and 360, but x can't be equal to 360. So the values here that we're taking are 0 and 180. Now for cos x equal to -1/2, you've learned to solve trigonometric equations using the cast diagram. So cos is negative in the second and third quadrants, and to find a related angle, inverse cos of +1/2, that's an exact value, which is 60 degrees. So 180 minus 60 is 120, and 180 plus 60 is 240. So we now have 4 answers, 2 from this equation here, sin x equals 0, and 2 from cos x equals -1/2. So we know that x is equal to 0, 120, 180, and 240. And those are our final answers, folks. So just now would be a good time to pause the video and take this example down in your notes before coming back for example 2. So welcome back, folks, and we've got example 2 this time. We want to solve cos of 2x equals cos x for x lying between 0 and 2 pi. So our solution then, we can see here we've got a double angle, we've got cos of 2x. Now, we've got 3 expansions here, one involving both cos and sine, one involving only cos, and one involving only sine. So how do we choose between these? Well, if we look at the rest of our equation, involves cos. So surely it would be sensible then to choose 2 cos squared a minus 1. So we're replacing our cos 2x with 2 cos squared x minus 1, and that is equal to cos x. Now I'm going to subtract my cos x from both sides of the equation because I can see that I've got a quadratic here, and in order to solve a quadratic, I need the quadratic equal to 0. So that gives me 2 cos squared x minus cos x minus 1 equals 0. And factorising that will give me 2 cos x plus 1 cos x minus 1 equals 0. Now by the null factor theorem, that means that 2 cos x plus 1 equals 0 and cos x minus 1 equals 0. And solving each of those equations for cos x, we get cos x equals -1/2 and cos x equals 1. Now let's take each of these separately. So we've got cos x equals -1/2 firstly, and we know that cos is negative in the second and third quadrants. To get a related angle, inverse cos of positive a half. In your head you're thinking 60 degrees possibly, but we are working in radians, so we write down pi over 3. Don't ever write down the related value in degrees. So we're working in pi over 3, so that means for our cast diagram we've got 0, pi can be represented as 3 pi over 3, 2 pi represented as 6 pi over 3. So our answer from our second quadrant is 2 pi over 3, and from our third quadrant 4 pi over 3. Now for the equation cos x equals 1, we can use our graph here, and we can see that cos x is equal to 1 at 0 and 2 pi. So we have 4 answers here. We've got 0, 2 pi over 3, 4 pi over 3 and 2 pi. And we'll just have a quick look at the graphs, and we can see that our answers are the points of intersection of the graphs of y equals cos 2x and y equals cos x. So you can see we've got 0 here, 2 pi over 3, which is approximately 2.09, 4 pi over 3, which is approximately 4.18, and then we've got 2 pi, which is approximately 6.28. So you can see those are our answers there. So just now would be a good time to pause the video and take this example down in your notes before coming back for example 3. Okay, welcome back folks. So example 3 this time, we want to find the points of intersection of the graphs y equals 3 sine 2x plus 1 and y equals 2 sine x plus 1 for x lying between 0 and 2 pi. So the solution then, we've got 3 sine of 2x plus 1 equals 2 sine of x plus 1. Remember, we're trying to find points of intersection. These are both y equals, so that means that 3 sine of 2x plus 1 must be equal to 2 sine x plus 1, as I've shown. Now, we can subtract 1 from both sides of the equation, and we'll be left with 3 sine of 2x equals 2 sine x. And you can see that I've got my double angle here, sine of 2x. I've only got one expansion for that, so I can substitute that in. So I've got 3 multiplied by 2 sine x cos x equals 2 sine x. Expanding the left-hand side, I've got 6 sine x cos x equals 2 sine x, and then I can subtract my 2 sine x from both sides of the equation so that everything is sitting on the left-hand side here. I can then take out a common factor of sine x, or rather 2 sine x, and I've got 2 sine x bracket 3 cos x minus 1 equals 0. And using the null factor theorem, I know that 2 sine x is equal to 0 and 3 cos x minus 1 equals 0. That means that sine x is 0 and cos x is equal to 1/3. So for sine x equal to 0, we can examine the graph, and you can see here that we've got points at 0, pi and 2 pi. And for cos x equal to 1/3, we can see that answers will appear in the first and the fourth quadrants. So inverse cos of 1/3 is 1.23, and just a reminder, we are working in radians here. So 1.23 is one of our answers, and our other answer is 2 pi minus 1.23, which is 5.05 to 2 decimal places. So that gives us the answers 0, 1.23, pi and 5.05. And if we just have a wee quick look at these graphs, so y equals 3 sine 2x plus 1 and y equals 2 sine x plus 1. And you can see the points of intersection here at 0, 1.23, pi, which is approximately 3.14, and 5.05. So just now would be a good time to pause the video and take down this example in your notes before the screen goes blank, and then complete the assigned exercises for today.